bad. I'm okay. How are you?
I'm good. So what are we doing tonight?
Algebra review / calculus preparation.
Okay,
is what
cool.
they're calling it.
Limits. Calc prep is probably limits. I don't know. You got some problems?
Yeah, it's all fairly basic. Just sort of a renewal of algebra techniques.
Okay.
So the first one is just simplify the expression, and it's 3 times the quantity of 3t minus 4 minus the quantity of t squared plus 2 minus 2p times p minus 3. Or sorry, it's all one variable.
Is it T or Tom or Peter?
T, like Tom.
Unfortunate that our alphabet has so many things that end in the letter or the sound E.
Yeah.
And is that everything?
Yeah, that's it for this one.
Okay.
Oh no, sorry. It's 2t times t minus 3.
Like that?
Yes.
Okay. Start from the left. Read me the next line. Go ahead.
9t minus 12 minus t squared minus 2 minus 2t squared plus 16.
Good. Now combine like terms.
Negative 3t squared plus 15t minus 14.
Good. What else? Give me something tougher. That's not going to challenge you. You wish that would be the toughest question on your final, huh?
Yeah, I do. That'd be nice. So y to the 4th.
Excuse me.
Sorry, this is still just simplification.
Okay.
Times 6 minus y times 5 plus y.
Which should we do first?
Foil.
Okay. What do you get?
Y to the 4th times 30 plus 6y minus 5y minus y squared.
Okay. And then it's always the middle two terms that can be combined. It's almost, I've never seen the first or the last term. In other words, there's not going to be any other numbers and there's not going to be any other y squareds.
Right.
So the only thing you have to combine are those two terms. Now what's the last row?
Y to the 4th times negative y squared plus y.
Okay.
Should I distribute?
I would just go left to right until we get to the end, and then state it as a polynomial with the first term being the highest degree.
Okay.
It's a little hard to go right to left. It just is.
Right.
And you should always kind of use the same method if you can. In other words, let's make that 30y to the 4th. What's the next term?
Plus y to the 5th.
Okay.
Minus y to the 6th.
All right. And that actually would be acceptable if they have not said put it in standard format. standard format being this.
Right.
But I generally wait till the end to do that, just because my mind is used to working from left to right. So I don't want to go from right to left until I have to.
Okay.
Okay, what else?
Okay, so now I've got some actual equations.
Okay.
First one is 3x squared plus 5x plus 1 equals 0.
Now, whenever you have a quadratic, there's always kind of a question as to how much time you should spend trying to factor it. Let's give it one shot at least. If it doesn't work, there's only one set of factors for the number 3, and there's only one set of factors for the number 1. So there's not going to be a lot of energy wasted here trying to factor this. And the moment we realize that we cannot factor it, then we go to the quadratic formula. So first step, try to separate the x's.
Right. So 3x on one side.
That is the only way they separate. In other words, you don't want to separate them as 3x squared times 1, ever. You always want to separate the x's, and then the factors take care of themselves. Signs have to be plus plus, 1, 1. That does not produce 5x in the middle. That produces 4x in the middle. And since that's the only way to factor 3 and the only way to factor 1, that means that there's no solution by factoring. We got to use the quadratic formula.
Okay.
Now, that took me about 30 seconds to decide. You don't want to spend 5 minutes trying to factor and then say, oh, this doesn't factor, I'm going to use the quadratic. Because you're always going to be timed on tests. So there's kind of a fine line as to how long you spend trying to factor it. So if I'm solving this, I'm going to next, since I can't factor it, my only other alternative is the quadratic. Tell me what it is.
The quadratic, or the quadratic?
Well, the quadratic filled in. X is equal to what?
Negative 5 plus or minus the square root of 5 squared minus 4 times 3 times 1 all over 2 times 3.
Good. I would have asked you the general formula, but I knew you knew it. So normally I always ask everybody start with the general formula. Okay, that's 25 minus 12, so that's 13 over 6. And that's a sufficient answer.
Right.
What are the two x values that equals?
Negative 5 plus root 13 over 6, and negative 5 minus root 13 over 6.
All right. What else?
X to the third minus x to the minus x squared in parentheses. Sorry, the first two terms are in parentheses. Plus the quantity of 2x minus 2 equals 0?
For the sake of argument, I'm going to remove these parentheses. Neither one of them is necessary, right?
Right, yeah.
Doesn't change anything. The normal way you're going to be given this problem is this way, without the parentheses. Okay?
Okay.
Now this is a cubic. They have not yet taught you how to solve cubics, have they? Have you had the rational factor theorem and the remainder theorem, the zero remainder theorem?
No.
Okay, so you don't really know how to solve a cubic. And believe me, it's really difficult. It's like 5 times harder than solving a quadratic. There is no cubic formula. Unless you have a certain type of cubic, which this one is. And the type of cubic that I'm talking about that can be solved without too much difficulty is where the ratio of that coefficient, let's call that A, call that B, call this one C, and call that one D. If A over B equals C over D, then there's an easy way to solve this. Okay? That's what's required. The ratio of the coefficients, the first two coefficients, have to be the same as the next two coefficients. And in this case, they are.
Right. Okay.
I've got
1 over 1 equals 2 over 2.
Well, it's 1 over minus 1 equals 2 over minus 2. And it has to be exact. In other words, you could not have 1 over 1 equals 1 over minus 1. That's not the same. It's got to be the same. Okay? So, if it is the same, then there is this particular technique called grouping that I can use. And what it involves is factoring out the greatest common factor from each term, or each binomial term. So what's the greatest common factor on the first set of parentheses?
X squared.
Leaving?
X minus 1.
And the second one?
You take out 2, leaving X minus 1.
If these two terms are not the same, you've made a mistake, or it can't be solved by grouping. In other words, as long as those ratio of coefficients are the same, these two terms are always going to be the same. And now you do something that you haven't probably done a whole lot of in algebra, which is to factor out a binomial term. Not a monomial term, but a binomial.
Oh, right, yeah.
So I'm factoring out x minus 1, and what's left?
X squared plus 2.
There's your answer. Now, sometimes that can be further factored, but when you have sum of squares, it does not factor nicely. In other words, that actually only has imaginary factors, the second term. So you don't really break that down. Here, I always do this where I point with my pen and you can't see it, but if I point with my cursor, you can see it. So this x squared plus 2, if that was an x squared minus 4, then I would factor it further into x minus 2 times x plus 2. But when you get this term, which is called an irreducible quadratic, and the definition of that means you cannot reduce it without employing imaginary numbers, then you have your answer. And all of that's equal to 0, which means x equal 1 That's your only real solution.
Right.
This one produces two imaginary solutions. So you can still list those imaginary solutions depending on what the question calls for. If it says solve for x, then you probably want to keep going, and you would want to say, okay, that also means that x squared plus 2 equals 0, which means x squared equals minus 2, which means x equals plus or minus the square root of minus 2, which is plus or minus the square root of 2i. So there are three solutions. There's one of them. There's the other two. And it's worth noting that imaginary solutions always come in pairs. You never get a single imaginary solution. Never, ever. In other words, you might have an imaginary solution that's 2 plus 3i. If so, you always have the solution 2 minus 3i. They not only come in pairs, they always come in conjugates. So that if I was a solution, then minus I is a solution. If 3i was a solution, then minus 3i is a solution.
Okay.
Usually when you're breaking a... Now, let's go back here because they didn't give you a tough one. I want to make this slightly tougher. Just slightly. But it throws everybody. In other words, by making this 1 degree more difficult, it causes 95% of students to miss it.
Okay.
Here's what I'm going to do. I'm going to make this a minus sign instead of a plus sign. And make that a plus sign. Okay?
Okay.
Now notice that the ratio of the coefficients is still the same. That equals minus 2 over 2.
Negative 2 over 2. Okay.
Yeah.
Right.
So I can still use grouping. Okay? Here's the problem. I can put parentheses around that without changing anything. But I cannot put parentheses around that.
Right, because that implies
because
the
that's
2 is negative.
being subtracted. So for me to actually put parentheses around the second two terms, I got to change the sign. In other words, I got to make it x cubed minus x squared in parentheses minus, and now it's going to be 2x minus 2. In other words, these two are the same. And that's what you always want to make sure you do, is when you add parentheses that you don't change it.
Okay, right.
And notice what I had to do. I had to change the sign on just the plus 2 part of it. Okay? Now, when I factor out the greatest common factor, I end up with this. And I still got x minus 1. So I know I've done it correctly because that's the same as that. And it's the same as what I started with. That's the key when you're doing these. Never change it. Make sure that every row is the same as the previous row. Now, when I go to finish this problem, I get x minus 1 times x squared minus 2, and that's not an irreducible factor or quadratic.
Right.
That goes to x minus 1 times, you know what? They call it the difference of perfect squares, but it doesn't need to be perfect squares. I can apply the difference of perfect squares factoring to any two numbers.
Oh, okay.
Is all it is. It's the square root of that and the square root of that.
Okay.
If I multiply that by that, I get x squared minus 2.
I like that.
Yeah.
Never been taught that.
Well, it's worth knowing because it means, yeah, it means you can actually factor anything. In other words, if I said factor x minus 7, that's square root of x minus square root of 7 times square root of x plus square root of 7. So it really does factor, even though it's neither one of them is a perfect square.
They're not integers.
No. Well, they're not perfect square numbers. In other words, the way they teach this is they start out by teaching it as the difference of perfect squares. That's a perfect square. That's a perfect square. So it comes to x minus 2 times x plus 2. But the fact of the matter is that it doesn't have to be perfect squares. I can factor that just as easily, and neither x nor 7 is a perfect square number.
Right.
But it still factors into the square root of x minus the square root of 7 times the square root of x plus the square root of 7. And when you're factoring cubics, frequently you come down to that quadratic factor becomes a difference of two numbers, which means it always has real solutions. You can keep factoring it. In other words, if I come up with an answer like this, most mathematicians would say that's it. You don't take that any further, because that is an irreducible quadratic. But if I come up with an answer,
really.
What's that?
But like you said, not really.
Well, no, really. In other words, there's no zero. That term is always positive. So usually the only reason you're factoring something is to find the zeros. Well, that's called an irreducible quadratic because there are no zeros. There are only imaginary numbers, which are imaginary. Don't mistake the word. They're not real numbers. They're imaginary. So I wouldn't take that down any further. Whereas if I came up with an answer like this, I would change it and take it all the way down. It would be x minus square root of 3 times x plus square root of 3.
Okay.
In other words, these are each linear factors, and they're real factors. This problem is going to cross the x-axis in 3 places. It's going to cross it at 1, it's going to cross it at 1.7, and it's going to cross it at negative 1.7. So it's going to do something like that. Whereas this up here is only going to cross the x-axis at one place, right there. So that might do something like that. Excuse me, that's crossing it at 2 places. You would, if you've factored a cubic and you only get one real zero, then might look like that. It's only going to cross the x-axis in one place. This part does not cross the x-axis.
Right.
What else you got, William?
So this next one is
as bad as our GoToMeeting audio is, our phone audio is that good.
yes.
Which is not usual. Most people that I have to use phone audio with is terrible. I can't hear them. They can't hear me. Ours is amazingly good, which is ironic and odd.
Yeah, I'm glad there's no issues with it.
No, really. I don't even hardly notice the difference when we use phone audio. Whereas I have one student that I can't understand a word he says on phone audio. And he refuses to go out and buy a $15 microphone. All right, what else you got, William?
So the next one's another simplification problem.
Okay.
And it's going to try my best to explain it. It's a little complicated. It's the fourth root. There's a big fraction on the inside, and on the numerator, it's t raised to the power of 1/2 times root 5 times t.
T inside the radical or outside?
Inside, sorry.
Okay.
And then on the denominator, it's 5 to the power of 2/3.
Okay. That's
So
it?
that's it. Yeah.
The secret here is to put everything in the same notation. Right now we have a mixture of radical signs and fractional exponents. Okay?
Right.
So let's take this whole thing and first of all make it t to the 1/2, 5t to the 1/2. That's our numerator. All over 5 to the 2/3. So that's what's inside the radical, right?
Right.
Now we're taking all of that to the 1/4 power.
Okay.
Now it's a relatively straightforward problem. In other words,
Right.
now it's just multiplication of exponents. So tell me what we got. What's the numerator going to be? Just do it term by term and then we'll continue to simplify.
It's t to the 1/8
Okay.
times 5t to the 1/8.
Actually times 5 to the 1/4 times t to the 1/8. You see why? The 5 is inside the parentheses. It's being taken to the 1/2 also, and it's also being taken to the 1/4. So you have to include that to the 1/2 and to the 1/4. Excuse me, that makes it 1/8.
Okay.
In other words, the 5 is to the 1/2 and it's also to the 1/4. So it's 5 to the 1/8. And in the denominator, it's still 5 to the 2/3. Now, let's simplify the numerator. What's the t become? Just work left to right. Take all the t's.
T to the 1/4.
That gets rid of that and that. Now the only thing you have left is that. Subtract the exponents. What do you get? What's 5 to the 1/8 divided by 5 to the 2/3? What's our common denominator?
Is it 24?
You know what? 24 is definitely a common denominator. It may or may not be a least common denominator, but who cares? What we only need is a common denominator. And it turns out that it is the least common denominator, but I don't really care. Even if it were not the least, hold on, let's see, it's going to be 16. Even if it were not the least common denominator, it would still work. It's just the least common denominator ends up making your math a little easier. But a common denominator, even if it's not the least, still works. So what's that equal to?
Negative 13 over, 5 to the negative 13/24.
Okay, and now most math wants your answers with positive exponents only.
Okay.
So what does that become?
So it becomes t to the 1/4 over 5 to the 13/24.
And if, I also would normally say that if they give you the problem with a radical sign, you should give them the answer with a radical sign back. But
Okay.
they mixed it up on you. They gave you a problem that had a mixture of radical signs and fractional exponents. So I can't really say that they would want an answer back in radical form. Now, the truth is that in all higher mathematics, fractional exponents work far better than radical signs. So this is a far better answer than 4th root of t divided by the 24th root of 5 to the 13th. That would also be acceptable. But there's a reason in higher mathematics that you don't like radical signs. The same reason you don't like radical signs with logs. They don't, everything is dependent on the exponent. With logarithms, with calculus, all higher math, you want an exponent. So when you see a radical sign, you convert it immediately. That is not that. That is this. That's allows you to do calculus. You can't do calculus from that step. You got to have an exponent to do calculus. So that answer we came up with is my preferred answer. Now, there are various forms. If you happen to have it, notice that this is the same as, right? That's the same as what we came up with, and which means I could then say that it's t to the 6th over 5 to the 13th, all to the 1/24th power. So I could even have an answer like that if you happen to be looking at multiple choice. In other words, there's all kinds of ways to represent this answer. There's 3 of them that are all the same. All of the ones that I have circled are all the same. Let's see. I think we're out of time. Yeah. When's your final, William?
I already had my final, but we've got a quiz coming up next Thursday.
Oh, okay. So you must be on like a quarter system? You're not on a semester system?
No, we are. It's PreCalc / Trig is a senior class at RV. And the way my old school worked is that it was a junior class, so I was lined up to take it. So now I'm a junior in the senior class, and the seniors' last day was last Friday.
I get it.
So we already took the final for them. Now there's like 6 of us juniors doing nothing.
So you got one more quiz and then you're done.
Yeah.
All right. Well.
Yeah, and I've got an hour-long session scheduled for next Tuesday.
Great. I'll talk to you then.
Thank you, Mr. Cowan. Have a good night.
You too. Bye-bye.